Welcome back to section 11.5, part 4. In this section, we are starting out by looking to see when to use the law of cosines versus the law of sines in solving a triangle. And in general, you want to look to see first if you can use the law of sines. If you can use the law of sines, then you can go ahead and do that. And if not, then we look to see if we can use the law of cosines. So go ahead and pause this video and try to fill out when to use one versus the other. This first case is if we're given two angles and any side. Now if we're given two angles, that means that we actually know all three angles because we can just subtract the two angles from 180. And if we know all three angles and one of the sides, then that tells us that we can use the law of sines because we've got an angle and the side opposite of that. The second case is if we're given two sides and an angle opposite one of them, and just like the reasoning that we just did in the first part, we can also use the law of sines because we have this information. If we've got two sides and their included angle, that means that we do not have the side across from the angle that we know. We cannot use the law of sines. So this is an example of side angle side, and we have to use the law of cosines for this. We've also seen a case when you're given all three sides. So if you're given all three sides and we don't have any of the angles, then we also need to use the law of cosines. I apologize for the handwriting. I am trying really hard to make it look legible, but with the stylus it is giving me a lot of trouble. So hopefully it'll look better in the next videos coming up. In this last case, we've got a right angle and at least one side and one other part. So if we know a right angle and at least one side and another part, then that means that we can actually use trigonometry. So if we know it's a right triangle and we have at least two other pieces of information, whether it be an angle and a side, or this angle and another side, or two sides, whichever case it may be, because we've got two pieces of information and we know it's a right triangle, then we can use trigonometry, so katoa. In these last four problems, we're first going to determine whether to use the law of sines or the law of cosines based on this chart right above. And once we know which to use, we're going to write out the equation first and then solve the triangle. So looking at the first one, we've got angle A is 56, angle B is 22, and side A is 12.2. And because we know an angle and the side opposite from that angle, we can use the law of sines. So we're going to set this up using the law of sines. That is 12.2 over sine of 56 equals B over sine of 22. And we can cross multiply this and simplify to find angle side B, and side B comes out to 5.51. Now because we know two of the angles already, we can go ahead and subtract from 180 to find the last angle. And you could have done this step first. It doesn't matter whether you did solving for the other angle first or if you solve for the side first. So we've got 180 minus 56 plus 22, so angle C comes out to 102 degrees. And the last thing that we need to find is side C. So because we know the angle for C and we know the other information about this triangle, we can set up the law of sines to find side C. And side C comes out to 14.39, and we want to round this to the nearest hundredth. So side C is 14.39, and we've got angle A, B, and side A given to start. We found angle C, side C, and side B. Go ahead and look at parts B, C, and D and see if you can figure out which you should be using the law of sines or the law of cosines. Pause this video and then resume it when you're ready to go over which you should be using. Now for part B, we are not given a pair with an opposite angle and side. So this is a side angle side case, which means that we need to use the law of cosines. To set this up using the law of cosines, we are given angle B is 47 degrees. So we want to write this in terms of B. So we've got B squared equals 20 squared plus 24 squared, so side A plus side C, minus 2 times side A times side C, and cosine of angle B, which is 47 degrees. And we can simplify this. So this comes out to B squared equals, that's 400 plus 576 minus 960 cosine of 47 degrees. And we get that B is equal to, once you simplify the right side, then we can take the square root of both sides, and we get that B is equal to 17.92. And same thing as the lesson on law of sines. When you are doing problems like this on the assessment, I expect you to round to the nearest hundredth for the sides and use that rounded answer when solving the rest of the triangle. So now that we've found one of the sides, we've got angle B and the side across from it. You can now use the law of cosines or the law of sines. It doesn't matter which you use. So for this problem, I'm just going to go ahead and use the law of sines and solve for angle A. So we set this up for angle A using the law of sines, and we've got sine of 47 over 17.92 is equal to sine of A over side A, which is 20. Cross multiply, solve for A, and angle A is 54.7 degrees. Now that we've got angle A and angle B, we can subtract from 180 to find angle C. So angle C comes out to 78.3 degrees. The next problem is number C, or letter C. This problem, we're given all three sides but none of the angles, which means that we need to use the law of cosines. And when we use the law of cosines and we're given all three sides, we need to start out by determining which of the angles is going to be the largest and solve for that one first. So because side B is the largest or the longest of the three sides, that means that we need to solve for angle B first. So we need to set this up in terms of B, and then plug in side B, side C, and side A. Or again, here we can rewrite the formula to start so that you've got cosine of B equals A squared plus C squared minus B squared over 2AC. And again, it doesn't matter whether or not you rewrite this or if you just plug in those sides to start. And when you're simplifying this, make sure that you either, if you're going to put all of it in your calculator at once, then start out with parentheses, close those parentheses before you divide, and then make sure you divide by this whole quantity, so that also needs to be in parentheses. Or you can simplify it in steps, so do 12.2 squared, 9.8 squared, 15 squared, simplify that, show it, and then keep going. So here we've got cosine of angle B is equal to 0.083138. And to get angle B, we need to do the cosine of this answer, which comes out to 85.2 degrees. And at this point, you can go ahead and finish solving the triangle. So we still need to know the other two angles, and you can use the law of sines for that. And using the law of sines, you can either solve for angle A or angle C next, and then take that angle and subtract from 180. So I'm going to show that, and you can pause the video if you want to check your solution, and then we'll go over part D. Angle A is 54.1. Now we subtract from 180 to find angle C. Angle C is 40.7 degrees. And looking at this last problem, we've got given angle A is 42 degrees, side B is 15, and side A is 12.9, which means that we've got an angle, side across from the angle, and a side next to the angle. And if we draw that out, we've got angle A is 42, side B is 15, and side A is 12.9. And because side 2, 12.9, is smaller than side 15, we need to check and compare this to the height. This might be an ambiguous case. So if we solve for the height, we get the height of the triangle is 10.4 approximately. And this shows us that side 2, so side A is side 2, is less than side 1, and it's greater than h, the height, which means that there are going to be two possible triangles here. So one will be going over here, and then a smaller one over here. And we need to solve both of these. So on the front side of the notes, we went over when to use one versus the other. And if this is the case for the ambiguous case, it's recommended that you do the law of sines. For this problem, I'm going to show it using the law of cosines. In the future, I recommend that you just use the law of sines because the law of cosines requires you to use the quadratic formula and can get a little bit more complicated. So we're going to be using the law of cosines for this, and we are given angle A is 42 degrees, which means we need to write this formula so that we've got a squared equals b squared plus c squared minus 2bc cosine of angle A. We can plug in the numbers that we have, and it's going to look a little bit different. So this is minus 2 times 15 times c cosine of 42. And all the times that we've used the law of cosines before, we've only got a variable in one place that we're solving for. But here we are solving for side C, and we've got side C here and side C here. And if you notice, the C is squared, which means that this is going to form or turn into a quadratic. And we're actually going to be solving a quadratic here, which means that we will get two possible sides for side C. So if we simplify this, when we simplify it down, it comes out to 0 equals, and we've got c squared minus 30 times c times cosine of 42 plus 58.59. We can simplify the cosine of 42 and multiply that by negative 30, so we've just got one coefficient in front of c. This is c squared minus 22.2943 times c plus 58.59 is equal to 0. And at this point, we can go ahead and use the quadratic formula to solve for the variable c. So we've got c equals, that's going to be negative b, so positive 22.2943 plus or minus the square root of b squared minus 4 times a, which is 1, times c, 58.59, all over 2 times a. Our a value is just 1, so it's going to be all over 2. And from here, we can simplify it down. You get two possible values for c. So we get c is 19.25. This is c1. And c2 is 3.04. So now that we've got our two values for c, we can go back over and look at the diagram. So C1 is 19.25. That represents this whole side. So if this angle is C, then C1 is going to be this whole side, which is 19.25. And then we know C2 is 3.04, which would be just this little length. So we still need to find our angles, B1, C1, and then we need to find C2 and B2. Now once we find B1, we can subtract B1 from 180 to find angle B2. So at this point, what we want to solve for is B1. And setting up the law of cosines, if we want to use B1, that means that we're going to be using side B. Side B is 15, that's 15 squared equals, and then we've got 12.9 squared plus, and if we're referring to angle B1, that would be the larger triangle, so C1 would be 19.25. Squared minus 2 times 12.9 times 19.25 cosine of, and then this is specifically for angle B1. So if we go ahead and solve this, simplify, we get that angle B1 is 51.1 degrees. So that means we can find angle B2 is just 180 minus 51.1 degrees. So that is 128.9, and because we have angle A, so we know angle A for both triangles is 42 degrees, and we have the angle B for each triangle, we can take angle B and B1, subtract that from 180 to find angle C1, and then do the same thing with the second triangle. So take A and angle B2, subtract from 180 to find angle C2. 86.9 degrees, and C2 comes out to 9.1 degrees. So for our final answer, we've got our first triangle, which has C1, angle C1, and angle B1, and then for our second triangle, C2, angle C2, and angle B2. This wraps up part 4 of section 11.4. Again, when you see a problem that has angle side 1, side 2, and you recognize that it's going to have 2 triangles, you can just stick with the law of sines and solve it that way. If you're going to go with the law of cosines, then after you've done the law of cosines to find C1 and C2, then make sure that you use the law of cosines again to find the remaining angles. Thanks for watching.